Ethan Keller, and I'm going to be showing you how to use OnShapePy. So the first step is to install it through pip. That's just a pip install OnShapePy, like that. Okay, so it installed. Then the next step, as you'll see in the documentation over here, is to specify the credentials. So the credentials are your access key and your secret key from OnShape that lets your computer access your OnShape account. So you can just copy this file here to be filled in into your home directory /.onshapepy. So the way you do that is you can just open up Atom and then do Command N or Control N and paste in those credentials. And your credentials you should be able to get by going here. That should bring you to the devportal.onshape.com/keys. You can do create new API key. And OnShapePy needs to write to your documents, read your documents, and yeah, that's it. Create API key. So now you can take your access key and put it over into Atom here. And your secret key. And put it into Atom. Okay. So now if I save this, Adam's going to ask where do you want to save it. So for Mac, that would be under users and then whatever your username is. I'm going to save it as .onshapePy. And Adam will warn me names that begin with a dot are reserved for the system. That's fine. So just say use dot. Okay, so now OnShapePy has the credentials, so it can connect to your account. So now we're going to be playing around with a particular OnShape model that I constructed a little while ago. It's just a cube with 5 different parameters. So you can see in the configuration here, or I can show you in the configuration pullout, the different parameters. There's length, height, and width. So those are all variables you can set. And then has fillet is a Boolean value. So it either does have a fillet or it doesn't. I can show you what that looks like. So if it has fillet, it has these rounded corners. Or it doesn't have fillet, it's just square corners. And then the fillet type can be circular or conic. So here I'll show that too. So if it has the fillet, circular just looks like the radius of a circle. And then conic is a little bit different. It has something called a row value. So let's experiment with changing those values through Python code. So the way you do that with OnShapePy is you first have to start it up, then you import OnShapePy. We have a convenience import at onshapepy.play, so you can just do from onshapepy.play import star. Now the way you connect a particular part, so we're going to make a cube variable and connect it to our cube part. So the way you do that is you use the part initializer and you grab this URL and you paste it into the part initializer as a string. If everything goes right, yep, it connected. So now if we do cube.params, we get back a dictionary that shows the variables as pint quantities, the has fillet as true, because that's a Boolean, and the fillet type as a string, conic, because that is a table. So conic refers to the key that we saw right here, this name parameter, which can be either circular or conic. Okay, so now if we want to set any of those parameters, so say we wanted to change the height, we can just do cube.params equals, and you can do as many of these in one change as you would like. We'll set it to, here I set the height, so we'll do h. We'll set to 300 millimeters. That's just a pint quantity. So you can put it in like that. Okay, so now supposedly it's set. Yep. The cube did grow as we expected. And now I'll show you setting multiple at once. So we'll turn off the fillet and we'll set the width to 150. Okay, so we can see it did those two operations. Now, the last and perhaps coolest thing about this is you can also get data from the model back into OnShape. This means you can do implicit geometric calculations within OnShape by selecting different entities using called measure distance. And there's a link to that in the documentation. So, for instance, this measure distance measures the diagonal of the bottom sketch and then sets a variable to that distance. So the variable is set to 180.278 millimeters. So if we, for instance, you can see you could calculate the square root of 300 millimeters squared, or 150 millimeters squared, plus 100 millimeters squared, and that should be equal to that value, 180.278. Now, if you wanted to do something a little more complicated, you could do the 3D diagonal, which I have measured here, just by selecting two points across the extreme. So you can see that is a little bit different. That's 350 millimeters, this happens to be. Okay, so if you want those measurements, you can get those with a cube.measurements call, like that. And every time that you change the parameters, those measurements will update. So if we actually turned on the fillet, the sketch won't change, so the diagonal should stay the same, but the diagonal 3D will change slightly. So let's turn that on to true. And now let's do cube.measurements. And indeed, the diagonal stayed the same, and the diagonal 3D changed slightly because it's beveled now. The last thing we'll look at is just a fun example of the cube dancing around with this example notebook I made. So this shows you how you can use complicated scientific libraries that are available in Python to derive OnShape parts. So this example shows a cube that changes its height based on a random number generated from NumPy every 0.5 seconds. Because of the latency from my computer to the server, it might change a little less often than 0.5 seconds. But we will run this, and we'll see the cube jump up and down switch over fast enough. So you can see the height is changing a little bit to some random value. So I call that the dancing cube. Enjoy. I can't wait to see what everyone builds with OnShapePy. Good luck.